Here's an idea. Why don't I create this series where I create a bunch of apps all just to display two simple words. Hello world. That's it. Nothing else. Nothing fancy. Okay, maybe it might get a bit fancy, but nothing else. In the end, the output is always the same. Just hello world in any medium or form that I can think of. Hopefully, as the series progresses on, the apps get more and more complicated. I don't know how many I'll create, but in the end, my vision is that I'll get a Rube Goldberg type of a machine app thing that does so many weird things in the background, but in the end, it just shows hello world somewhere. Yeah. So to start off first, we need to create a simple hello world. And so that's what we'll do. And so here is the also popular printf hello world statement. It just does what it says on the can. Print the string hello world. And so if I run it, you can see it says hello world. Can you see it? Okay, the press any key to continue is added by the stupid thing there and it's not me. So hello world is there, so mission accomplished. Now since the series just started, I won't make something utterly complicated. I think this is the best time for me to introduce something called the Endianness of something. The Endianness of a data or something is just a way to describe how it is saved or stored or represented. Let me explain. Let's take our decimal counting system as an example. If you look here, 1234, you know very well that the 1 in 1000s is the most significant digit because it has the highest weightage in the number. Then number 4 in the ones is the least significant digit because it has the lowest weight in the number, blah blah blah. So how does Endianness come into here? Now suppose that I have 4 boxes and in each box I will put in 1 digit, either front to back or back to front based on this number. If I put in 4321, don't ask me why I do that, but if let's say I'm storing a number like this, you spell least with L, you spell little with L. This is the little endian representation of my number 1, 2, 3, 4. If I return 1, 2, 3, 4 as per normal, then I have stored it in a big endian manner. So how does this concern the numbers in my computer? Now the smallest addressable memory in your computer is a byte, and a byte contains 8-bit. Normally 8-bit. Can't think of any other computers that use other than 8 bits. Maybe back then got, but now don't have. Okay, but 8-bit is for 1 byte. Normally, you deal with integers that are 32 bits long when you're doing shit on your comp. So how does your computer deal with such a long number? 32 bits or how to store in 8 bits? Cannot lah. So what it does is, it will take the 32 bits number and cut it into 4 parts. How do you divide 32 into 4 equally? Actually you can. You can. So 32 divided by 4 is 8 bits. Ngam ngam lah. So 32 bits is just 4 lots of 8 bits. Powers of 2 are always the best. Now to make things a bit simpler, I'm going to represent our example number with 8 hexadecimal digits. But in case you don't know, hexadecimal means 16. A base 16 number just means that we're representing in powers of 16. The numbers go up from 0 to 9, then to A, B, C, D, E and F of 15. Once you go to 16, you roll back to 0 and you put a 1 to the next door neighbor. Like how when you count up to 10 in your decimal number, you roll back to 0 and then you plus 1 to the next. You get what I mean. You carry a 1. Yes, that's the word, carry. Right, anyway, this is our example number. Now when I want to store this 32-bit integer in my memory, your system can choose to do 2 things. Store it in a big endian or store it in a little endian manner. What it does is, it will separate this 32-bit digit into 4 8-bit digits. So now you can see my integer is broken into 4 different bytes. Now this byte here is the most significant byte. This byte here is the least significant byte. If my system chooses to store it this way, then it is storing in a big endian manner. And little endian is this way. Okay, so why am I talking about this? I'm going to do something very interesting. Instead of printing a hello world straightforwardly like that, printf hello world. I'm going to encrypt it in the form of integers. Okay, but first we need to find out what endian is my computer storing its numbers in. I have declared here an integer, 32-bit integer lah, and I nicely put it so that the integer is 11223344 in hexadecimal, so that once the computer splits this up into 4 equal parts, I have 4 bytes, and they are nice numbers for me to see lah, so I can tell that they are my number. And then here we introduce pointers. Now pointers are just addresses in memory. So where in a memory you want to look for your value basically. So I'm asking this character pointer, this pointer, right, to look for the address of my integer x. So a, the variable a now stores the address to my integer x. And then now the next line would just to print out what are the values at that address location. Don't worry too much, I'm just finding out how is the computer storing the number 11223344 in base 16. So if I run this thing, you can see it says 44332211, which means that this computer is storing the number, any number or any data type in a little endian manner. The least significant byte comes first. So how do we use this knowledge to make our hello world slightly more complicated? So now that we know that the computer stores data in little endian mode, we can now construct our hello world string using only integers. My brain isn't a table of numbers, okay, so I need to consult Google to convert my text hello world exclamation mark into hexadecimal digits, and these digits are based on the ASCII standard lah. And over here I create an integer array. I'll tell you why there's a fourth element here when I only need 3. So I'll write the HELL first in reverse, because once this is stored in a memory, it will flip it around. Nicely enough, hello world exclamation mark is 12 characters long, so I can split into 3 groups of 4 characters. When you're making a string, at least for C, you need a null terminator. Your system will look for a very special character with the number 0 as its ASCII value. Null terminator. If there's no null terminator, when I ask it to print the string, it will continue printing all the way forward until you can see a 0 somewhere in a memory. Not a good thing, and normally a lot of exploits use this fact. So I need to terminate my string, and that's why I have the 4th element here to put in a 0. Now after that, I just have to print the string. I print f, and %s format specifier just tells it that my next argument will contain a pointer to the string, and this pointer is x. Don't ask me how it became a pointer, but once I put x like that, it takes the address of my first element of x. So if I run this thing, you should be able to see hello world. Oh look, hello world! Mission accomplished again. Now to make things even more obscure for someone who's going to read this code somewhere later, we should just convert all of these hex digits into decimal. So I've consulted the calculator, and these are the numbers for this integer. So if I were to run this, I should get hello world again. No, look, hello world. Yeah, with that done, I hope you have enjoyed it as much as I did. So next time, instead of telling people straight in the face, hello world, you tell them this set of numbers. Done. Easy.